First, let's see what is a graph data model. So real-world data is naturally connected. Traditional data modeling focuses on entities, not relationships. For many applications, for example social media applications, there is need to model both entities and relationships effectively. And this is where a graph database comes to the rescue. A graph database can persist relationships in the storage layer. This leads to highly efficient graph retrieval operations. Graph databases are NoSQL databases because there is no dependency on a schema and there is no constraints on data model. There are a few different types of the graph data model, and the one we are going to talk about is called property graph. A property graph is a structure that is composed of vertices and edges. Both vertex and edge can have properties. So as you notice, vertices is the plural noun for vertex. So let's see a property graph example. Imagine a few entities. For example, we have person number 1 and person number 2. We can have any other objects in this graph. For example, a cell phone and a laptop. These objects can have relationships. For example, person 2 knows person 1. Person 2 uses a laptop, and both person 1 and person 2 are using the same cell phone. These objects can have properties. We can have the first name and last name property for person number 2. We can have the first name and edge property for person number 1. And as you can see, you are not forced to have the same set of properties for objects here. My laptop can have the model property, and the value for that will be Surface Pro, and my cell phone runs the Android operating system. So what you just saw is an example of a property graph. Let's take a look at the components in this graph in more details. The first components are vertices. These are discrete entities such as person, place, or an event, and these are commonly nouns. For example, person, cell phone, laptop, etc. Then you have the edges. These are relationships between vertices. For example, a person knows another person. The edges are commonly verbs. And finally, we have properties. These are information about the vertices and edges. For example, you can have the name property for a person, or you can define how long person 2 knows person 1. So the properties for vertices are commonly adjectives, and properties for edges are commonly adverbs. Let's go back to our property graph now and replace our objects with their conceptual equivalent. So as you can see, I have 4 vertices here. Person 1, person 2, cell phone, and laptop are all vertices. The knows and uses relationships are edges. And first name, last name, operating system, and brand name are all properties. So as you can see around you, the real-world objects are naturally connected. Here are a few scenarios for which you can apply the graph data model. You can store social network relationships in a graph data model. The recommendation engines in e-commerce websites can be modeled into graph data models. You can use graph data models to model maps. And finally, graph data models can be used in Internet of Things.